Today, we're going to discuss how to analyze your Go build times so that you can improve them. So Go is designed for fast compilation, and that's a lot of the reason why people like it. However, sometimes you notice that your builds have gotten a little bit slower or that certain code changes cause an unexpectedly long recompile time. So in this article, we'll show you how we go about analyzing our compilation times and what we can do to improve them. So the most important thing you need to know about the Go build cache about the Go build is that it has a cache. Go is very good at caching your build artifacts. If you make a small change and rerun the build, the rerun will be significantly faster than a fresh build because Go will reuse these cached artifacts from the previous builds. However, if you update the Go version, change build flags, or perhaps pull in some new or different dependencies, Go may end up doing a full rebuild from scratch. So the first thing to improving your build time is making sure you're using a build cache. It is enabled by default in like a default environment, default development environment, but that may not be true for your CI/CD system. So double check to make sure you're using the build cache in your CI. So for example, if you're using GitHub Actions setup Go, it has the caching turned on by default, and it gives you some notes here. If you have multiple GoSum files in your repo, you will need to do some configuration to make sure all those parts are cached. And once again, this doc is the setup Go action. All right, let's jump and run some builds. So first, we're gonna do an analysis of a clean build. So to do an analysis of a clean build, we go clean cache. That will wipe out the existing build artifacts. And then when we're doing performance analysis, we use the command time and wrap it around other commands like time echo high. That didn't quite work. Let's try another example. Time sleep 1. And so at the end, you get these metrics. User time, system time. So this is user code versus kernel code, but oftentimes this is what you care about, the time like you spent waiting for this command to return. And another note about time is you can have different time commands. In this case, time it says shell reserved world, so I'm using Z shell. So this time is built into my shell. You can use a more standard time like user bin time. If you want, it may be more standard across multiple operating systems. So let's see what it gives me. So the output is a little bit different. Okay, let's go to do the actual build. So I cleared my cache. Now we're gonna do the build. So I will do time Go build, and the flag that we're gonna use first is debug trace. And it's gonna dump it to a file. We'll call debugtrace.json. And then I need to set a few flags just for my build, and these are, because I'm building a big project, so it needs a few flags, and I'm gonna output it to a file, and I'm specifying what am I building. So I'm building this command fleet package. Let's go ahead and run it. And I'll pause until it finishes. Okay, it finished. It looks like in this case, it took 21 seconds total. Like not too bad, but sitting around waiting for 21 seconds, maybe there's something can be done, or like, why is it taking 21 seconds? So let's go ahead and look at this debug trace. So if I look at the top of this debug trace, it kind of looks like this. This is actually a standard format, a trace event format. And a popular tool to look at this is Perfetto. So if I go to the web page, important thing, it tells you the shortcuts, WASD to navigate the trace. And then I simply open the trace file and I try to remember what I called it, debug trace. And we pull it in, debug trace right here. And there we go, there's our trace. So using WASD, I can zoom in, move around using the keyboard. It's nice. So right away, over here, you see this long green line. So really, this is the bottleneck of my build. It looks like it's taking most of my build is this one thing. And if I look at it, it's the Go SQLite 3 library. It took a little over 16 seconds to compile. And we know this is slow because most of it is C code, so it's using CGO, and Go does not, at this point, is not able to parallelize the CGO compile of this library. So what can we do about it? Well, we can analyze where this library is being used and try to perhaps not build it into every build. Maybe have a special build just that includes that library. Perhaps some other things that can be done. One thing we try to do is we try to move this dependency up. We see that it starts down here, so we thought, well, maybe we can gain a little bit of time by having the build start earlier, by kind of moving it up to be a dependent of the main command fleet compile. But that didn't actually end up helping, because then the subsequent link step, which I think is one of these link steps down here at the very end, that ended up being longer. So we weren't able to get speed up from that. But I do want to mention that generally, this is not a big issue, because this is a library that gets pulled in. So it only gets compiled once. Typically, you're doing recompiles. Like I mentioned before, you're using a build cache. So the recompile is what kind of developers care about as far as development experience. So let's go ahead and try a recompile. All right, so I'm going to go ahead and make a small change. So I'm going to make a small change to a file. So one way to make a small change is to do something silly like var underscore equals bozo. This type of change will be part of the compile, but it's going to be optimized out. And I'm going to add it to a file that I know is changed frequently. Server data store MySQL. Not a file that's changed frequently, but a package that's changed frequently. Come on, okay. And then we're gonna basically run the same command again. Yep. See, a lot better. A little over 1 second. I still dumped it to debugtrace.json. So let's go back to Perfetto and look at this new debug trace. So open trace file. We're going to open the same trace file because I overrode it. And there we go. So it looks a bit differently. First thing you notice is that there's this load packages and errors step that looks like has a lot of information about it, what exactly is running, and it is all running on the main thread. So it's interesting how this first step is not being parallelized. Maybe something the Go team could look into. I've got 16 threads on my machine, and all the work is taking the first 300 milliseconds is being taken on one thread. Then this is nice. Everything's being parallelized until we get to this point, and this is the package I actually modified. So I modified this package. It's taking a little over 600 milliseconds, which is actually about half, if not most, of the build, right? So this is the part that we could improve, right? This is actually a pretty big package. So this could easily be cut down if we split this big package into smaller packages, right? So the incremental build I bet we could easily speed this incremental build up by half a second. You know, maybe not a big thing in a big sense of thing, but if you have a development flow that is continuously compiling the code, like a flow that's looking for changes and then just recompiles or reruns test, you know, that would matter, you know, waiting an additional half second for results. So next, what we want to find is why dependencies are included in the build. In our specific example, we want to find why that SQLite 3 package is included. Who exactly is using it? Now, in a previous video, we talked about how to find Go package dependencies, and we'll put a link in the description. But in this case, we're going to go ahead and use the debug action graph flag to do that. Let's go ahead and jump into the code. So I think I already tried this. So same command. We're gonna go clean cache. Same command, except we replace the debug trace flag with debug action graph command. So same go command as before, and these build flags are just something specific for my build. And let's go ahead and run this, and I'll pause the video while it's running. Okay, the build completed. It took 21 seconds, in line with our expectations. Action graph JSON is the output, so let's go ahead and open that up. And it kind of looks like this. You have the package that's been compiled, and then you have dependencies of that package. And as we can see, this Go SQLite 3 package actually has dependencies. So it's not only that big green line that we saw earlier. It also, there's some additional compile time to its dependencies, and then it tells you the command that's run, and we see here that it is compiling C code, right? And we can parse this file, right? The IDs correspond here, so let's just pick a random one, dependency 145. So we'd search for ID 145, ID 145, and we can see it depends on the math package. Makes sense. But another way that many people analyze this action graph file is using this open source action graph tool that's available on Git, and you can install it with this command. So let's go ahead and use one of the subcommands of that tool. We're gonna do action graph-f action graph.json top. And it is showing the things that take the most time, and this is in line with our expectations, right? This is what we saw from the trace tool, debug trace tool as well. So another command, and where we want to go is we want to know why this SQLite dependency was pulled in. And this tool generates a dot file, which can then be visualized. So let's go ahead and do that. Basically same action graph command, but instead of top, we're going to say graph, and then we're going to pass it why this package specifically, and it's going to generate a dot file that we're going to send to action graph SQLite 3 dot. And then to visualize this dot file, we can convert it to SVG, which can be done with the open source GraphWiz tool. It has a dot command. This can be installed with our homebrew or some other methods. So let's go ahead and use that. I already have installed. Which dot, you see, I have it installed with homebrew. And I'm going to say dot. We want the SVG package. We're going to pass in the file, and we're going to output action graph SQLite 3.svg. And then let's visualize this. So I'm going to open this file. And it opens in the viewer. I mean, SVG files can be viewed even by your web browser, but in this case, it opens up Inkscape for me. So I see up top is what we're compiling. And then you can kind of see the dependence graph. This fleet is depending on GoVal dictionary, which is depending on NVD. And NVD is the one that's depending on that Go SQLite 3 package. So in this case, I see that the dependency tree is fairly simple, right? And I know this server vulnerabilities package is only used for specific use cases in our application. So for development experience purposes, it would be fairly straightforward to have an environmental variable or a build flag that kind of excludes this part of the code from a build. So that way, if I'm doing fresh builds pretty frequently, I could have a better development experience. All right, one last thing to mention is that these flags that we showed, the debug action graph and the debug trace, do not have official documentation. And if you look at the Go source code, it even says in the comment that these are undocumented, unstable debugging flags. So if you want to dig in further here, you would need to go to the Go source code and see how they work exactly. All right, that's it for today.